Hello, everyone. I'm Diao Xing, a teacher from Jiangxi Environmental Engineering Vocational College. Today, I'm going to talk to you about water pollution control technology, biological treatment technology component. First of all, students are invited to look at the period from 2013 to 2020, growth chart of the capacity of China's wastewater treatment plants, and calculate the cumulative growth rate, as shown. By calculating this, we can find that MAUs between 2013 and 2020, capacity of our sewage treatment plants, there has been a very large increase, cumulative growth rate of 55%. You can see that the growth rate was very fast during this period. Next we will learn the basic process of activated sludge method, aerobic biological treatment with activated sludge as biomass medium. We are as shown in the picture. You can see that the sewage will first enter the aeration tank. In the aeration tanks, we'll be pumping air into them. Activated sludge in the presence of dissolved oxygen can treat organic pollutants in wastewater. The treated effluent flows into a secondary settling tank. In the secondary sedimentation tank, it is possible to put sedimentation of sludge in the sewage mixture. After settling, a portion of the sludge will, through sludge, return to the aeration tank of the system. A portion will also be discharged as residual sludge. Then the sewage, after settling in the secondary sedimentation tanks, water discharge is possible. This is the activated sludge. The basic process flow of aerobic biological treatment as the main media. So the basic components of the activated mud process and its function. Fabric. We can divide it into 4 parts: aeration tanks, secondary sedimentation tanks, sludge return systems, and aeration systems. Aeration tank is the main place for microorganisms to oxidize and degrade organic matter. Secondary sedimentation tank. It is to realize the separation of mud and water, clarifying the role of effluent thickened sludge. Sludge return system. Ensure that there is a sufficient and constant amount of activated sludge in the aeration tank. Aeration system. Its role is to supply the treatment process with sufficient dissolved oxygen and mixing and agitation. Basic requirements for the operation of the activated sludge process. The first is to have quantitatively adequate performance, includes settling properties and their composition, good stable activated sludge. The second is activated sludge, good mixing contact with wastewater, that is, mud and water should be well mixed. The third is to have enough dissolved oxygen. Then the basic parameters for the operation of the activated sludge process. First is the sludge return ratio. We generally use the letter R for. It represents the ratio of return sludge flow to influent water flow. The material balance of our conventional activated sludge process can be seen as follows. Through material balance diagrams, we can derive the sludge reflux ratio from equal to the ratio of return flow to influent flow of the system, as shown. Another fundamental parameter for the operation of the activated sludge process is the sludge retention time, or sludge age. It represents the average residence time of bacteria, indicates new sludge growth in the aeration basin, average residence time in the aeration tank, or in an aeration tank, time required to update all sludge, total amount of activated sludge in the aeration tank Vx. We can generally express this by multiplying the volume 5 by the sludge concentration x. It is related to the daily emissions from the system, ratio of the amount of residual sludge delta x, that is, theta c, equal to Vx divided by delta x. This formula calculates the sludge age of the system. Then the specific process parameters take values, generally based on the process employed and design conditions. Excessive sludge age. Then it is easy to lead to sludge aging, low activity, poor settling performance. If it is too short, it tends to lead to too much sludge activity, poor sludge loosening and settling performance, etc. Then as shown, the picture on the left shows the activated sludge in our microscopy. The figure on the right shows the settling performance of activated sludge with a dosage of simple concentration of suspended solids in the mixture. This is also a very important process indicator. We can generally denote this by X and XV. X can be expressed as mLSS. XV generally denotes mLVSS. Concentration of activated sludge per unit volume of aeration tank mixture, generally expressed in units of milligrams per liter. It responds to the amount of activated sludge in the aeration basin. Then in a push-flow aeration tank, general sludge concentration in the range of 2,000 to 4,000 mg per liter. In a completely mixed aeration tank, it is typically found in concentrations of around 3,000 to 6,000 mg per liter. The F value of domestic sewage is also its volatile fraction. In general, we can express the ratio of XV to X. Volatile fraction F generally between 0.6 and 0.8, and the small f value for industrial wastewater. Then it is generally based on experimental. There is also an important indicator of sludge settling ratio SV, and of course the SV30 is usually used. It indicates that the aeration tank, the mixture was left to settle for 30 minutes after. Volume ratio of settled sludge to its mixture, used for initial understanding of sludge in aeration tanks. Quantity and settling properties. Too low means too little sludge or too little sludge activity. Too high means too much sludge, or the settling properties of the sludge are too poor. Generally between 15% and 30% should be controlled. Sludge volume index SV, aeration tank mixing liquid after 30 minutes of resting, volume occupied by 1 gram of dry sludge. It reflects a combination of sludge settling properties. I control between 50 and 150. Less than 50 indicates good sludge settling performance, but the sludge particles are tightly packed. Excessive inorganic content, inactive. If too high, generally more than 200 will indicate poor sludge settling performance. Sludge expansion has occurred or is about to occur. Then our sludge return ratio and sludge concentration, as well as the return sludge concentration and sludge volume index, and the relationship between the sludge settling bottom is shown in Fig. These formulas can express the relationship between them. Please review it carefully after class. Okay, that's all for this lesson. Thanks, guys.